Alright, hi everyone, welcome to my YouTube channel, City of Elections. So in this video, we are going to handle question 6, question 5, 6, okay, 6, 7, and 8. But the thing is, before we can handle question 6, 7, and 8, there is something we need to know, which I think will be much, okay, which is this. So if we're able to complete that in this video, that's fine, but it's going to be lengthy. So this is it. Now, in order to differentiate between 2G and 5G cellular system, and then to list the technologies used in 4G, and then explain evolution of cellular communication system from 1G to 4G, all these three questions are related. So let's just do a breakdown of what's going on here. So evolution of cellular communication. All right. So evolution of cellular communication. Now recall that cellular communication is an example of wireless communication. Remember what we did in one of the videos where we said wireless communication, we defined it, and then we now mention some examples of some of its examples. So wireless communication, and then examples, mobile cellular network. This is it here. Okay, cellular network, cellular system, cellular communication, same, and talking about the same idea. So this cellular network, it's an example of wireless communication. So the cellular network, evolution of cellular network, where is the beginning? How from the beginning, that's from the first time, so first generation 1G. So from the first generation of cellular communication to the present time, so let's just stop at 5G. Okay, although some persons are talking of 6th generation, 6G, but let's just stop at 5G for now, because that's kind of current stage leading into the 6th one, but 5G. Okay, so before we even talk about the generations, okay, this cellular, what are we even talking about when we say cellular? Of course, when we say evolution, I think that one is clear enough. Change from one state, evolving, changing, let me say evolving from one state to another. Okay, I just like simple definition. There is more, it can be complex than that, but just leave it simple. Okay, so evolution. Then communication, of course, transfer of information, sending and receiving messages, information from one person to another person, and just like that. So cellular, just think of this one, cell. Just think of this cell. Now, a cell in communication, cell has to do with what? I think I downloaded the picture for it right here. Good. Now, when we talk about cell, this is what we mean. A region. Look at it. Let's say this can possibly be a community. Okay? Let's say a community. Or maybe a state or something like that. Now, in this community, or let me say region, let's use a region or area or whatever. Now, in this area, when you zoom in, you will see that there are base stations. Okay, look at these things. It's called a base station. Base station. Base station is what we locally refer to as max. Okay, mass. Some people call it mass, some call it max, different things like that. MTN mass. Oh, see MTN mass. See Glow mass. That's it. That's actually the base station. It's like a tower when you look at it, a tower. So that base station, it covers a certain range. So the base station and the area it covers is called a what? It's called a cell. So this is one cell. This is one cell. This is another cell. This is another cell. This is another, and so on, just like that. Are we getting it? So the communication where we use cells, this is what the idea of cellular communication. Is that clear? So if the something you can use to move about, something you can use to work, you can use to communicate, and you can move with it. Mobile, and you can use to communicate with the base station, communicate with other people. That thing is a cell phone. Cell, because it works with the cellular system, so it's a cell phone. Okay. Now, with that being said, I believe you understand the idea of cellular communication. So this working with cells, what's the evolution, okay, from the first generation to where we are now? So now, what we have to consider in cellular communication, what you have to consider in the evolution of cellular communication, we can just think of four things. Okay, four things basically. So for the first one, when we say how they work, so for the first one, we say how they work. What we actually mean is technology. That's the word. Technology. So what's the technology for 1G? What's the technology for 2G, 3G, and so on? Then when we say speed, the professional word, I hope we are following. When we say how they work, the professional word or the standard way to say it in communication is technology. Then for speed, the way we say it is what? The way it's said is data rate. Data rate. That's what they mean. Then for what can we do with it? That one is what? Service. Service or services. Then for how is signal sent and received? That one is what? Is switching. Switching. Okay? Switching. All right. So, with that being said, we are going to create a table now. I'll create a table here, and then we'll now fix in the different things into it. All right. So here is our table. So features, that means the things we look at for a particular generation. We look at the technology, we look at the data rate, we look at the services, we look at the switching. Okay, and I've explained what those things are right here. Okay, what we mean by those things. So, starting with the first generation. So for the first generation, now I think I should even start with the service, because this will give us the idea of why that particular technology, and then the data rate, and then the switching. So let's start with the service. So for the first generation of cellular communication, all they wanted to do was to allow people communicate, send voice. You speak wherever you are, and someone else will hear what you are saying in a different location. So the service was just what? Voice. That's it. Okay? So voice signal. Now, in those days, was to make use of frequency. That is, the note that if you want to send a letter to somebody, okay, you want to send a letter to somebody, you are going to do what? Put that letter in an envelope. Okay, you put this letter in an envelope. Now, the envelope is not the message, the letter is the message. So when you put the letter in the envelope, you are going to send the envelope which contains the letter. When the letter gets to the destination, when the envelope gets to the destination, the person who receives the letter or the envelope will take the letter out of the envelope. Are we getting it? So this process is also applied in signals, okay, in transfer of information, not digital yet. The first generation, they work with analog, okay. So this process of putting or placing the letter inside the envelope, in our case here, placing the message signal, the voice message you want to send, into another signal that can be transferred, that is known as modulation. Okay. Now the thing is this: our voice, when we speak, that voice is not something we can transmit over a long distance. So in order to transmit it over a long distance, we are going to place our voice signal, not later again, voice signal. We are going to place the voice signal Let's call the voice signal M of T. So we are going to place this voice signal inside the carrier signal. Now, this our voice signal cannot travel a long distance. It's at usually low frequency. This other signal is at usually high frequency, but this is not the message. This is the message. Are we following? So what's happening is that this our message signal we take this message signal and place it inside the frequency of this message signal. How that is done is not something we should handle in this video. I'm just trying to explain how come about the technology used in this generation. So don't worry much about it. After all, what we are trying to handle is this particular thing. To be able to state, or where's the question there? Okay, to be able to explain the evolution of cellular communication system from 1G to 5G. The question is not for you to explain the modulation process. What I'm talking about now is the modulation process, but it will just help you be able to recall the kind of technology that was used. Exactly. So the message signal being placed in the carrier signal. Now, if you place the message signal in the frequency of the carrier signal, it's called frequency modulation. If you place the message signal in the amplitude of the carrier signal, it's called what? Amplitude modulation. If you place the message signal in the phase of the carrier signal, it's called phase modulation. So in the first generation, what they did was to place the message signal in the frequency of the carrier signal. So that's what frequency modulation. So the technique used in the first generation is what? FM, frequency modulation. Okay. Now, in case anything here is not clear, please put it in the comment section. I will make a complete video on it to explain the thing deeply. If I decide to go deep into this one, okay, what is PM, what is AM, what is FM, and how is this mathematically done, how is it done in real life, if I begin to go deep into the process, this video will be very, very long. Already this video will be long. So if you want clarification on any part, let me know in the comment section. However, we still do our best to explain deep as much as we can that will be relevant to answering these questions here. Okay, so let's continue. So with this now, we've seen that FM is the technology used in this generation. However, not just FM alone. The thing is that since we have multiple users, you cannot give one particular frequency. You can't give just one frequency is in hertz now. Let's say this 0.7 hertz. Let's use this. This is just one frequency. Okay, but we have multiple users. Therefore, we have to divide. Let's say if we have a frequency range of, let's say, 30 hertz to kilohertz. Let me use kilohertz to 700. That's larger kilohertz. This is a wide range. This is a wide range. So what will happen is that we have to divide between this and this. We have to give let's say 32 kilohertz to somebody, 33 kilohertz to another person. Divide this frequency. So what we are actually doing here is frequency division, multiple what? Access. So in order for many people, a lot of users, because people want to communicate, okay? So in order for multiple users to access this, to access the first generation, that's in the first generation, for multiple users to make use of the cellular system, we have to do what? Divide the frequency. So that technology is known as what? Frequency division multiple access. Okay, so let me now have this one here as this FDMA. Okay, now bear in mind that in the first generation, all these things were what? Analog. What's going on? Analog. Okay, so the FM analog, the FDMA also what? Analog. Analog in the sense that what we are saying is continuous in time. Things in nature are continuous in time. So the first generation, they did not convert this thing. They did not convert that analog signal to digital. They did not do that conversion. They just received the analog, sent the analog. Exactly. So that takes us to the next thing. Data rate. What is the data rate of the first generation? Please and please, when you hear data rate, your mind should go to what? Bits. Bits, ones and zeros. Let me take these things off here so that I can do my next write-up. Or should I just wipe them all out? Okay, wipe these guys out. And whenever you hear data rate, bear in mind, guys, we are talking about what? Bits. Bits. That's what? Ones and zeros. So, ones and zeros, this is what? Digital. Or digital, okay? So, and for analog, you don't have ones and zeros in an analog. Are we together? You don't have ones and zeros in what? Analog. It's ones and zeros is for digital. So when you talk about data rates for the first generation, there is no data rates in terms of ones and zero, because there's no bits. How many bits can you send in 1 second? That is what? Bits per second. How many bits are you sending in 1 second? But this one, I would not have bits. So what the engineers or what people did at that time was to do what? Get an approximate value, which they took as what? 2 kilobytes per second. Okay? 2.4 kilobytes per second. This is what they use. Saying that this analog signal, this voice analog signal, is equivalent to 2.4 kilobits per second. That's in digital. That's what they just like, should I say evaluated or assumed, or it's the value they came up with, close value they came up with to use, since this one is analog, not digital. So the close analog equivalent of, the close digital equivalent of the analog, which is voice signal, is this one. That's what they came up with in the first generation. Okay, so we've gotten these three. Now the last thing we'll talk about in this particular generation is what? Switching. And I said switching just simply means how information is sent from the sender to the receiver. So if we have a sender here, and then it is, they are too close. We actually write that here. Okay, so how is information sent from this guy down to this guy? Now, so send, and then what? Receive, whatever. So now the thing is this: if you use a particular channel, one channel, when I say channel now, we are talking about frequency. Okay, one frequency given to this particular guy, bros, use this frequency until you are done. If you are true with your communication, what you want to do, then you can hang up. But all those while, when using this particular channel, even if you are talking or you are not talking, as long as you still have that channel to yourself, nobody will make use of that channel. That channel belongs to you and you alone until you are done. So you have a dedicated channel to a particular user. That system of switching is known as what? Circuit switching. So circuit what? Switching. Exactly. Very straightforward. One user having a dedicated channel. That's circuit switching. Okay? So that's for the first generation. Going over to the second generation, they wanted voice, yes, which we already have from the first generation. And they wanted what? SMS. Are we seeing it? They wanted voice and they wanted what? SMS. They also made use of circuit switching. They also made use of circuit switching, which I just explained in this one. Now, for the second generation, instead of staying with the analog, they improved towards digital. digital, digital. And what they did was, since you are now going digital, that means when they receive the analog signal, it will be converted to digital, so that they can now do what? Do two things. Instead of giving, instead of, excuse me, instead of giving one user, one frequency channel, what they are doing now is time slots. So multiple users can now use one frequency. Multiple users, okay, multi-users can now make use of what? One frequency. But the thing is that when using one frequency, each user will have different time slots for the same frequency. So user 1, user 2, user 3, user 1, user 2, user 3, all of them can now make use of the same frequency but at different time. Are we seeing it now? So this one now is what is known as what? Time division multiple access. Are we getting it? Now, in the same second generation, they also introduced another technique whereby different users can make use of the same frequency. They can even make use of the same time. But the difference is now codes. That is combination of ones, zero, one, different combination. This code is multiplied by the person's what? Signal. So therefore, even if you are using the same frequency and the same time slots, if you have a different code, it means your signal will not interfere with someone else's signal. So where you each user is assigned different code is known as what? Code division multiple access. So these are the techniques, the technologies used for second generation. So we'll now have it like this: time division multiple access, and then code division multiple access for the second generation. Are we following? Then for this guy, it's what? 64 kilobits per second. Now, other generations, they improve on it to have more, to have higher data rates. Okay, but this is what they have here. Most of these values are not something you just calculate for. Okay, experimental values, yes, calculations involved, but these are the values. Okay, kilobytes per second. Now, from 2 to 5. Okay, all are digital. Okay, so I don't need to even write digital here again. No need of doing this. No need. Now, in the third generation, okay, let's start with the service as usual. So, of course, voice is there, so no need to write it. SMS is also there. In fact, no need to even write voice here. Just bear in mind that everything this generation contain, this generation also will possess them, but just with additions and improvement. So now for this generation, what they actually focus on is what? Internet. Okay, so this is what they focus on. So since they need internet, therefore they need to cover what? A wider range of what? Frequencies. So wide what? Code division multiple access. Are we saying it now? The same code division multiple access, but with a wider bandwidth. That's the frequency range covered. Please note that bandwidth just means, I don't think I've said this before, but when we say bandwidth, let me quickly write what we mean by that. So when we say bandwidth, this is the, let's say you have 30 kilohertz and then 60 let me use 62 kilohertz. Now, the bandwidth just means from this frequency to this frequency. This is the bandwidth. Anything lower than 30 is outside the bandwidth. Anything higher than 62 kilohertz is outside the bandwidth. This is the idea of bandwidth. Range, just a range of frequency. Okay, so Instead of having just a small range of frequency, we are now dealing with what? A wider range of frequency. So this was wide band code division multiple access. The code division multiple access is the same thing we said before, the same thing we explained before, but this one is just wider. It covers wider range of frequencies. And for the kind of switching, circuit switching is still there. Circuit switching is still there, plus a new one which is called what? Packets switching. I'm going to explain this one. Packet switching. Now, for packet switching, instead of giving one user, like in a circuit, we give one user one channel, right? But in packet switching, we are combining the information, not one user one channel again, but the ones and zeros are combined into packets, and then sent at different times to the receiver. Then at the end, which is the receiver, what happens is that they are combined again. They are rearranged rather to fit the original way they were sent. So sent from the sender, they will now be arranged, separated into packets, sent, and then combined back. Okay, now this message is being divided into different packets. They don't take a particular route, a particular channel to get to the receiver. They take different channels, different paths, different routes to get to the receiver. Okay, so it's not like a circuit switching where all of them are taking one particular channel to the receiver. They take different channel, but they are arranged into packet. All the different packets, different roads to the receiver. When they get to the receiver, they will rearrange back to match the way the sender has sent it. So sender, then it's divided into packets, then different roads to the receiver, combined back again the way the sender sent it originally, so the receiver gets the original message. That's the idea of packet switching. Okay, then for this particular one, it's about 2 mega kilobits per second. This is the one that looks like something you just have to kind of memorize. Okay, so when we say 64 kilobits per second and 2 megabits 2 megabits per second, 2.4 kilobits per second, it just means in 1 second, for this one, in 1 second, 2 megabits are sent or are transferred or received in 1 second. Bro, that's fast. Okay, but it gets better. So for the fourth generation, what are we looking at in the fourth generation? Oh, there's something I did not add. Okay, so in the fourth generation, we are not just looking at internet. We are also looking at what? Live streaming. Internet. What's going on there? Internet. Then live what? Streaming. There's something I did not add here. Even video calls. Video. Yeah. Video calls. Okay, but live streaming in the fourth generation, even gaming also, online gaming. But of course, to do all these things, you need serious technology. And the thing is this: what was added? We still have our FDMA. We still have what we have different here is this. Now, we already know FDMA, but instead of just FDMA, something was added. So having frequency division multiple access. Okay, this frequency division, we can now arrange it in a way whereby this O here is what? orthogonal. Okay, orthogonal. That is, the frequencies can be divided into sub-frequencies, into smaller frequencies, sub-frequencies, whereby even if they are very close, they will not interfere because they are what? Orthogonal. Remember, orthogonal is what? 90 degrees. So a frequency that is close to another frequency, but one is at 90 degrees to the other, they will not what? Interfere. Are we seeing it now? So this one now allows more users to make use of the frequency because yes, we divided the frequency into, we divided the available frequency bandwidth, but we now divide those channels into sub channels again. That is, each frequency, that's those closed frequencies, they are orthogonal to each other, so they will not what? Interfere. So not just FDMA, but what? OFDMA is used. And one other thing used is what? MIMO. MIMO is what? Massive inputs, massive outputs. Okay, MIMO. Massive inputs and then massive outputs. So the idea is this: instead of using one or two or one or three or six antennas in a base station, let's look for that base station. Yeah, so a base station like this, instead of using one antenna or three or six antennas, we use multiple antennas, a lot of antennas, to send out a lot of outputs, and then at the receiving end, multiple antennas to do what? To receive it. So that's what? Massive inputs and massive what? Outputs. That's what's going on here. Let me clear now these guys. Okay, so that's the idea of MIMO and FDMA, OFDMA. Yes, I've explained that, and then MIMO just explained that. So this one now will now increase the rate of what? Data, because a lot of data is going out, because we now have a lot of antennas. We now have a lot of antennas sending out like receiving input. We have a lot of antennas sending out output, and this one now is what? 1 gigabits per second. Really high, very high. Okay, well, 1 gigabits per second. Then for this one is just what? Fully packet switching. Okay, switching. Yeah, fully packet switching. Everything is what? Internet protocol, all IP. So fully packet switching, no longer circuit and packet, but just packet switching, everything internet protocol. Okay, so then when we say all IP is what? Internet protocol. All IP meaning everything, both all IP meaning voice, data, anything you want to do with in terms of communication, all of them, they follow a set of rules. Those rules are internet protocol. And what the rules are is how you send, how data is sent, how data should be received, um, how data should be set in packets, and when they get to the receiver, how they should be removed from the packet and reassembled in the way they were sent. All those things, all those rules are the internet protocol. Okay, so everything now is based on packet switching, internet protocol packets. Okay, so everything is all on IP. Now for the fifth generation, the aim or the service for the fifth generation is what? Internet of Things. And then this let's say smart cities. Okay, whereby you have cars driving themselves in the street lights. Or okay, so I think not street. Okay, street lights, smart street lights. Okay, let me use that way. And then all these self-drive cars and things like that. So smart cities, let's even say autonomous autonomous vehicles. Okay, then remote surgery, where a doctor will be at a different location and carry out surgery at another location, a remote surgery. So all these things, to carry out all this kind of system, we need a smarter technology. So not just Memo again, but massive what? Memo, massive one. So I've explained Memo in the when talking about this one. So massive Memo. Then forming, beam forming. So what beam forming actually means is that instead of using the antenna to spread the signal, instead of spreading the signal is concentrated to a user. Okay, the signal is concentrated to a user. So you have something like, let's say, what's going on here? All right, so let's say you have a user here, and then you have your antenna. Okay, you have your antenna, funny antenna. So the beam straight beams to the user. Okay, instead of just spreading around, hoping it gets to the user. No, it's beam forming. Okay, this technology is really, really advanced. We're not even going to go deep into it, but it's really advanced. So they just have the idea that once you hear beam forming, know that the signals are sent directly, concentrated to the user. Okay, so that's the idea of beam forming. Then another technique is was millimeter wave. Millimeter wave, that is very high frequency, very what? High frequency. So this, remember, from this point to this point is a complete what? Wavelength. To this point, this is a complete what? Wavelength. So when you say millimeter wave, it means that the wave, let me try to do that. It means that the frequency is so high, it's so high that the length of the wave becomes so small that it's just maybe in millimeters. The wavelength becomes so small that it's just in millimeters. You know, this is a high frequency. Okay? And this is a low frequency. Okay? The amount, this one I did just now, this one, it means you can complete a lot of circles, a lot of complete circles in less amount of time. But for this one, before you complete this circle, another circle like this, it will take more time. So that's a what? A low frequency. But this one, yeah, but this one is a what? High frequency, because you complete a lot of circles in short amount of time. Okay. Now, so this is the idea of millimeter wave. All right. Yeah, you've done a lot. So we can leave that three. Now, of course, what is used is what? Enhanced. The same all IP, the same, what just happened? Yes, the same all IP, all what? IP, but what? Advance. And the all IP we talked about, that one is what? Packet switching. Or let me say full packet what? Packet switching, which is now all IP, but advanced in this case. All right. And then the last thing we'll now talk about is what? How many the data rate? Gigs, 20 gigs, gigabits per second. In 1 second, this number of bits, come on, that's high. That's high. Okay. So this is just it. So with this one now, we have gone through the evolution of cellular network from the first generation to the last generation. Generation after generation. Okay, so that's it. Am I missing anything? So with this being said and done, now we can go and address question 6, question 5, question 6, question 7, and question 8. I think question 9 and 10 also. Okay. Okay, so with all we've said, we can answer most of the questions now. So you can see that what we have here differentiates between 2G and 5G cellular system. Of course, we have the answer to that now. Look at what they have here. The features, technology and data rates. Technology, data rate, service, and switching. Exactly what we have on our table here. Okay, technology, data rate, service, and what? Switching. So what they want in that question is what? 2G and 3G, is that not so? So look at it, 2G and 3G. So like we explained here already. So for 2G, they use what? TDMA and what? CDMA. This one uses what? Wideband CDMA, which is there. And this one is up to what? 64 kilo bits per second. And this one is what? Up to 2 megabits per second. And then of course voice and SMS. Then this one multimedia and internet, circuit switching, and right, this one is packet switching, just like what we have here already. Oh, this one I removed the SMS. Sorry, okay. I removed the voice. I think I should just leave the voice there. The voice, okay. Alright. So yeah, that's that. So then the next question, which we've also addressed, list the key technologies used in 4G system. Look at what we have here. 4G system, OFTMA and what? MIMO. So of course I think here they have more. OFTMA, look at it. OFTM. Now, instead of before writing the A, you can leave it at multiplexing, which is what? Orthogonal frequency division multiplexing, which is OFTM. So the other one will now be orthogonal frequency division multiple access. This is the technology. Then making that same technology available to multiple persons. So you have OFTM and OFTMA. So I should even add OFTM here. Where? Yeah, I should add it here. OFTM. Okay. Then here, here, I think I added this in before, but I removed it. Add advanced OFTM. Okay, advanced. All right. So we can see then MIMO. We talked about this one also. Massive input, massive output. Then adaptive modulation and coding, and then internet protocol based network architecture. Then this number 8 is what we have done already. Explain the evolution of cellular communication system from 1G to 5G. That's what we just did. That's what we've done. Okay, it's quite lengthy, but that's what we've done already. Then the next one is this, to discuss the role of standardized bodies in wireless communication. This one is not part of that generation stuff, but these people are those people who ensure the role of standardization bodies in wireless communication. They ensure that what? The wireless technologies are globally compatible and what? Interoperable. The idea is that whichever technology you are using in your country, whichever means of communication, the technology used in your communication in your own country, it should be compatible. It should be what? Globally what? Compatible. Do we get it? So this is the main role of these standardized bodies, and some of these bodies include what? Just International Telecommunication Union, ITU. So IMT, the one of 2000, that's the one for 3G, and the one of advanced, the one for 4G, the one for 2020, that's the 5G guides. Okay. But for the third generation partners and project, this is another body. Okay, so what they do, develop technical standards for what? GSM, UMTS, LTE, and then 5G NR. Of course, we also have the International Institute of Electrical Electronics Engineers, and they are responsible for what? For what? Wi-Fi and WiMAX. Okay, so these ones are just standardized bodies. So you can actually just look at these things, but you understand that the role of these bodies. I think this question is just at this point. It's just at this point. What's their role to ensure that wireless technologies are what globally compatible and what interoperable? Okay. So what does this thing even mean? I've explained what compatible means, but I should explain this one right now. So for interoperable, it means they can work together. Compatible, they can exist together without conflicting each other. This one, they can work together. So this is the role of what? Standardization bodies. Okay. Now, then the last question, which we've also handled, in question 10, um, explain how MIMO improves capacity of wireless communication. MIMO, multiple inputs, multiple outputs, uses what? Multiple antennas at the, I think this should be transmitter. That should be transmitter. At the transmitter and what? Receiver, which we also explained in this part. Okay? We also explained that thing. Right, so then instead of one or two or three or six antennas, we are using what? Multiple antennas. Okay, at the receiver and the transmitter. Okay, so it uses multiple antennas at the receiver, sorry, at the transmitter and receiver. The benefit is that you have increased channel capacity because multiple antennas are sending signals, so increased channel capacity, then improve reliability through what? Diversity. It's more reliable, of course. Then higher what? Spectral efficiency. Spectrum is the range of available frequency. So you can now make use of more of the available frequency. So it's now efficient because you now have more antennas doing the job. Then better signal quality in multi-part environment. An environment where you have multiple parts, you have better signal quality because you have multiple antennas. Okay. Then MIMO enables parallel data streams to be transmitted simultaneously. Okay, calm down. MIMO enables parallel data streams to be transmitted simultaneously, significantly increasing data rates. Because you have multiple antennas, therefore you can send data parallel, like you are sending one data at the same time sending another data, the same time sending another data, different data, multiple data simultaneously because you have multiple antennas. And this one will, of course, significantly increase what? Data rates. Okay? So that's it. That's it. That's it. Okay, so we've covered the 10 questions. So, of course, leave comments in the comment section, like, share, subscribe, and I'll see you in the next video. Okay, thanks for watching and bye for now.